For over a century, Albert Einstein's general relativity has defined our understanding of physics. Its equations provide a highly accurate, continuous map of local space and time, predicting the movements of planets and galaxies with extreme precision, right up until the environment reaches the Planck scale. Inside a collapsing star, standard physics reaches a breaking point. As mass compresses, the curvature of spacetime increases until, according to the equations, it must form an infinitely dense point. This is the singularity. In a physical sense, a singularity is not an object, it is a mathematical failure. It marks the exact coordinate where our laws of physics produce infinities, effectively signaling that the theory can no longer describe reality. These impossible infinities suggest a structural flaw in our foundational assumptions. If gravity and smooth, continuous time lead to a mathematical dead end, the geometry we use to measure them may be fundamentally incomplete. Recent deep space images from the James Webb Space Telescope have surfaced a physical anomaly that echoes this mathematical crisis. Astronomers have identified little red dots, objects in the early universe that are both incredibly massive and extremely compact. In standard models, a black hole of this mass should possess a massive accretion disk of gas. As that gas spirals inward, friction generates temperatures high enough to emit intense, detectable X-ray radiation. The little red dots possess the required mass and redshift, but they are completely silent in the X-ray spectrum. There is no evidence of an accretion disk or the mechanical destruction of matter. If mass can exist at this scale without the local causal process of accretion, it suggests these objects are operating on a metric that bypasses our 3D understanding of time. This leads us to the C-field framework, a system where time is an emergent byproduct, not a fundamental constant. Resolving the little red dot paradox requires a move away from the binary limits of E equals mc squared toward a non-local geometry that accounts for these silent, supermassive nodes. The C-field framework begins with Axiom 1, the unary level, a fundamental, indivisible unit below the Planck length, with no internal space or time. Axiom 2 defines the binary level. These units form instantaneous connections, a network of pure entanglement before distance emerges. Axiom 3 describes the ternary level. When billions of these binary connections aggregate and vibrate, they generate the 3D observable universe. Under Axiom 4, space and time are redefined as measurement protocols. They are not the fabric of the universe, but the tools used to track state changes within the ternary grid. Time is the discrete, path-dependent count of non-identity between two states. It lacks a smooth, continuous metric. It is a rough quantity, representing the sequence of transitions within the network. Because time is an emergent byproduct of these state changes, it cannot act as the fundamental parameter governing the universe's most extreme dynamics. Einstein's mass-energy equivalence relies on a rational exponent, the integer 2. This squared value forces spacetime into a smooth, periodic, and local relationship where cause and effect are strictly balanced. The C-field framework replaces this integer with an irrational value, n, representing the non-periodicity of entangled states. An irrational exponent yields an infinite, non-repeating decimal sequence. This injects non-periodic energy into space, allowing instantaneous, non-local interactions that a standard timeline cannot track. In this model, the energy of emergence is expressed as an inequality. The total energy is greater than or equal to m times c to the power of n. This creates a surplus known as non-local saturation energy. This surplus provides the mechanical engine for the universe. It is the fuel used for fractal growth and densification, rather than a simple expansion into empty space. The universe is not a passive balloon. It is a living network utilizing irrational energy to actively increase its own informational complexity. In 2026, researchers Daniel Jampolsky and Luciano Rizzola presented a potential solution to the singularity problem. They modeled the gravastar, where the collapse of a star is halted by the pressure of an internal mini-universe. Applying Axiom 5 of the C-field, we see a transition rather than a mini-universe. When matter compresses past the Planck limit, it sheds its 3D ternary form and returns to the binary C-field. This core acts as a cosmic socket, channeling non-local energy upward into the 3D grid without consuming surrounding matter. This explains why the little red dots lack X-ray emissions. They are not accretion-driven black holes. They are stable nodes that do not require the mechanical ingestion of gas to maintain their mass. Instead, they radiate a blue continuum directly from the irrational entanglement of the C field. They are powered from below, not from the surface. Within this framework, cosmological redshift is not the stretching of light through a vacuum, but the visual metric of the universe's mycelium-like network densifying its nodes over time. The observational silence of the little red dots is highly consistent with the C-field model, suggesting we are witnessing nodes of a living universe rather than holes in spacetime. If the C-field contains an infinite source of saturation energy, the structural integrity of reality depends on a mechanism that prevents mathematical divergence. The geometry of the C-field framework requires a 720 degrees spinor rotation, a Mobius topology, to maintain stability across different levels of reality. In this topology, a wave completing a standard 360-degree rotation arrives inverted. It must complete a full second rotation over the twisted path to return to its original origin. Integrating the primary bases over the Mobius manifold gives us the prime soliton equation. The core challenge lies in the denominator, E minus 2m. When energy and mass reach mirror image equilibrium, this hits zero, causing the mathematical amplitude to explode into an infinite singularity. Without a specific stabilizing factor at this exact coordinate, the transition between the binary network and our 3D world would result in total mathematical divergence. The stability of the prime soliton equation is maintained by the d theta term, which functions here as the observer. Mathematically, a line integral requires a specific reference frame to reach a finite value. This reference frame, the observer, acts as a boundary condition at the exact intersection of the 720-degree twist. By providing this perspective, the observer grounds the infinite irrational flux of the C field, effectively regularizing the equation and allowing the energy to manifest as a stable, observable reality. This completed framework suggests a universe that does not rely on a fundamental, linear timeline, nor does it expand into a void. Instead, reality functions as a non-local mycelium network, constantly utilizing irrational entanglement to generate increasing emergent complexity. The anomalies found in singularities and little red dots function as visible markers of a universe evolving through its own internal complexity. They are the evidence of a cosmos growing into its own awareness.